Welcome to Spring LIB.
Okay, so you're starting with your racemic mixture, which I'm just going to put an R here. The rest of the molecule sort of doesn't matter. And the idea is that one, in a standard kinetic resolution, right, you've got one, okay, can turn into two, supposing that you have the correct stereoisomer of your racing of one, right? That is right. The kinetic resolution essentially is that because this is a what would you call it? Basically an SN2 type reaction, that if you have one R, it can turn into one S or 2S. But that if you wanted to go through the reaction in a manner that would turn it into 2R, right, the barrier to that is far too high. So all your 1R will eventually turn into 2S, and basically none of it will convert to 2R, right? That's like your kinetic resolution, is that when you're done, you'll find that you collect basically no 2R because the barrier was too high, but you will collect 2S, right? So basically, if you start with a racemic mixture, you'll get a yield of like 50% and a high EE of your product because you don't make any 2R. You're just not going to make the incorrect enantiomer, right? But if you add phosphonium bromide, what now becomes possible is that if you have the wrong enantiomer, if all of a sudden you have the R enantiomer of your substrate, it can undergo SN2 type reactions with the bromine of the phosphonium bromide, right, to convert your R your S1, I should say. This is S. It can convert your S into R, right? Which is the enantiomer that you need to be able to convert into 2S, right? That's the low energy pathway. If your substrate is R, it can undergo the reaction, turning from 1 into 2. So what happens is the picture of your energy diagram changes. Now you have your sort of your any S that you have, any one S, right, can change. What we saw is that the addition of phosphonium bromide means 1S can turn into 1R. And then 1R can be transformed into 2S. And just as before, the barrier going from 1S to 2S is still prohibitively high. So all that's changed then is that you have this interconversion path from 1S to 1R, which can then turn into 2S, right? So if you start with a racemic mixture, right, you have 50% 1S and 50% 1R. Over time, all of your 1S will become 1R, which will then become 2S. Because now you have this pathway, and that pathway specifically is that a bromine ion from your phosphonium bromide can perform SN2 on your 1s to turn it into 1R, right? That's any of your 1s can be turned into 1R, which can then transform via the enzymatic reaction into 2s. So all you're doing basically when you add something like phosphonium bromide is that you turn a kinetic resolution into a dynamic kinetic resolution, where previously your picture might have looked like this. For 1s, you had this insurmountably high pathway to 2s, right? And for 1r, you had this not insurmountable pathway to 2s, right? But these were basically two different pictures, and all you're doing is linking them with this interconversion step. I could say like interconversion.